Good afternoon, ladies and gentlemen. I'd like to acknowledge my co-author, Dr. Einl Berry. And if you notice the title, we're talking about 16-year trends. A number of presentations before me, they've talked about sort of long-term monitoring, long-term trends. And sort of given the knowledge that we have, 16 years is not short, okay? However, probably is not long enough to qualify as a long-term trend. So, and hopefully you'll see some of that in the data that we present. It probably is somewhere in between, okay? This is a great setup. My eyesight is not like it used to be, and I have a nice little screen right here. But just a bit on what the purpose of the work that we did. And in general, to characterize a state of the historical ambient air quality so we can understand potential cumulative effects. Sort of one of the core scientific questions is that we think we can answer with some of these data are what is the extent to which the pollutant levels have changed over time? Very straightforward. These are the pollutants that we looked at in our analysis. Many of the presenters before have discussed them. And in terms of the method that we used, there are a couple of probably acceptable methods. And our experience would be that if the signals are strong enough, and what you're measuring, it doesn't really matter, all right? However, if it's not, you may see some differences depending upon the method that you use. And I'll try and point that out when we actually look at some of the data. So all that we've done here is draw data from the CASA data warehouse, which was provided by Wood Buffalo Environment Association. And for a given year of hourly values, 8,760 hourly values, we've identified various benchmark concentrations right from your median or your central tendency all the way up to near your upper bound, your 98th percentile. And we've done that for each year and just performed simple ordinary least squares regression to identify what the best fit line is and actually the slope of that line. That would give us the indication of the trend. I think the other thing that's worthwhile noting is the type 1 air rate that we used is 0.05. People that work in this area would probably recognize that's not very strong, okay, as criterion, that really it's not, okay? So, the data need to be robust, and so your type 1 air rate needs to be a bit lower before you can be a bit more confident. If you're curious, the publication that we have in the Science Journal Environment International describes a lot of this methodology. So this is a illustration that one of the sources of information to try and understand which pollutants might be of interest. We drew upon Environment Canada's National Pollutant Release Inventory. And we show a slide here that within a 70-kilometer radius around Fort Mackay, these are all the different facilities. They're not all oil sands. There's a gravel operations. There's also an extraction facility, all right? And they all reported various types of emissions into NPRI, all right? And I'm showing you two types of pollutants that, these are from 2002 to 2012, so sulfur dioxide. Primarily, most of the data would come from these CEMS, continuous emissions monitors. And what we see over this 11-year period is really not very much. There's really no noticeable trend. On the other hand, when we look at oxides of nitrogen, the data actually look pretty good. Right? Looks like a fairly sort of well-fit trend. However, the data that are used to to actually that go into the NPRI database are both based on instrument measurements and calculations. So there's can be some uncertainty. Probably these, what I'm showing here underestimates actual emissions because of the complexity of sources and the ability to report them all. Okay, if we start to look at some trends, so these are your 16-year trends. I'm showing you for Fort McKay, this is nitrogen dioxide, and also for the Patricia McInnes station in Fort McMurray. And in both cases, they do look like increasing trends at your upper percentiles, perhaps less obvious at your lower percentiles. So if we actually look at the regression fits and ask that question whether or not they are significant, what I'm reporting here indicates the direction of trend. So their little triangle suggests it's increasing. If the little bar, no change over the reporting period, and significant at a p-value of 0.5. All right. So it'd be suggesting at both locations we are seeing some trends. Are they large? I would not think so. I would suggest that notable trends are on the order of a couple of percent at least per year. All right, but anyhow, statistically, it is significant. Sulfur dioxide, if you recall, the emission data really showed no sort of clear direction in terms of the amounts of emissions that were occurring from year to year. And we do see sort of the same indications that no substantial indications of a trend. The other thing that would be notable, a suggested trend decreasing at your 80th percentile, for example, and we've just simply rounded off that annual increase is less than 1 ppb. That's not necessarily a large amount, okay? Again, it's only a 16-year period. Particulate matter and ozone, just from other data that we've looked at elsewhere, we did not expect to see anything. This is in the community of Fort McKay, and likewise for ozone, we did not expect to see anything, and that's what's being indicated, all right? Carbon monoxide, this is at Fort McMurray Athabasca Station, so that would be the only community station that is measuring carbon monoxide. And it's indicated to be decreasing at this particular station. However, if you look at your trends and the rate of change, they're not very strong, okay? I actually threw another slide in here after we saw these data because we started asking questions about carbon monoxide because it is an urban pollutant. And we were interested in terms of motor vehicle pollutants, carbon monoxide and nitrogen dioxide often get mentioned as pollutants from motor vehicles. So we looked at that particular station, the nitrogen dioxide trends, and what we're seeing are small suggestions of increase at your higher percentiles. So while I don't show you these slides here because I submitted the presentation, we did the analysis after the presentation, is we also were interested in comparing for the same time period what's happening at the urban stations in Edmonton and Calgary. And what we are seeing are the exact same things for carbon monoxide. I can tell you that the levels are about twice as high for your different percentiles, but they are decreasing. On the other hand, for nitrogen dioxide, I can tell you that the levels are about 50 to 75% higher for the similar percentiles. They are also decreasing. So we're still trying to understand what could be happening, but largely in a strictly urban environment such as the city of Edmonton or the city of Calgary, both your NO2 and your carbon monoxide levels are going down. The data are robust, that is to say the amounts that they are going down are not small. On the other hand, we're seeing something slightly different here, okay? And we don't quite know what that really is due to. Total reduced sulfur, there's been lots of discussion on the reduced sulfur and the odor-causing compounds. This represented a unique case. These are your various percentiles that we're actually showing. We're just showing the upper percentiles, your 90th, 95th, and 98th. And in the end, we decided not to analyze trends. And the reason why that was is there was a 3-year period in which one of the oil sands facilities actually were doing things at their facility, and it resulted in what is reported to be over a 50% decrease in terms of the TRS emissions from their facilities. We understand that there are some uncertainties in that. However, knowing that, it doesn't make sense to actually compute a trend, so we did not. On the other hand, what we did is we just compared the 98th percentile concentrations to the TRS emissions from NPR database, and they do suggest a relationship. That is to say, the higher the emissions that were reported, the particular 98th percentile concentrations seem to be related to that, given these uncertainties. So, I think clearly there is a relationship between the two. Total hydrocarbon, what we saw at Fort McMurray and Patricia McInnes were somewhat small suggested increases. Again, increases of that level I probably wouldn't be too concerned with, that they're real. Right? In fact, if you look at Fort McKay, THC, look at your percentiles beyond 2010. So if you looked at what's happening over a 4-year period, they're going down, okay? And this is very typical. You tend to see variation in your data, suggests that your time period is not long enough to try and determine a true trend. Fort Chipewyan, for all the parameters that we looked at, really there was no indication of any type of trend. I think it's important to note that where the monitoring station is located, it's far away, all right, in excess of 100 kilometers from some of these activities. So, there is a fair bit of sort of activity in the atmosphere and not much happening for these pollutants at that location. I just wanted to talk about, we also looked at exceedances. I know there were some data that Dr. Percy presented, and we're seeing sort of the same things from our analysis over a much period of time, over the 16-year period, excuse me. We were interested in, were any of these pollutants showing signals of exceedances that merited some additional attention? And in fact, when we add up over the 16-year period, we are seeing that PM 2.5 showed a fair number of exceedances. So what we did there was simply looked at the time series of the data over that period. There's a lot of data that's smushed into these graphs here, but if I could just draw your attention, is those red bars are at this 30 microgram per meter cube. That's the Canada-wide standard. If you look at those sort of those peaks that exceeded and then look down to the horizon, you'll find out that similar to what Dr. Percy was reporting, they're occurring over the summer. And probably associated with smoke-related or biomass burning events. And particularly where you see the strong ones, the very high peaks, it is possible to look at satellite data and quite readily confirm that that's actually what is what is happening, okay? Okay, last slide. So what did we learn? Well, suggested small increasing trends from this period, and no meaningful SO2 trends, not much to say about ozone, PM 2.5, carbon monoxide suggested to be decreasing in Fort McMurray, however it's quite small. Not much to say about total hydrocarbon. We do see clear differences in the community of Fort McMurray from the station monitor. And then as I just referred to, that there clearly is a role with PM 2.5 exceedances related to forest fire smoke. And sort of what are the implications for the future work? I think WBEM and the JOSEM process are sort of well situated and organized to continue capturing sort of valid data over a longer period so that we can get a sort of a better understanding of what long-term trends really exist out there. Thank you very much, ladies and gentlemen.
So before we take a quick break, are there any questions? Is there someone over this way?
Warren, I struggle with this idea of trends because we know, for example, in the region over the last 10, 15 years, emissions of all of those things you talked about, with the possible exception of SO2, have gone up, in some cases significantly. And so if you're not measuring a trend upwards and you've got emissions that are increasing, there's a problem, right? Because you should be seeing a trend upward. And so my comment, my question, I guess, would be, is the statistical approach that you're using the right tool to assess trends? And we can have a debate after, but I don't think it is, frankly.
You're supposed to ask me an Evie question, David. and that's a very fair question. In many cases, scientists like to sort of simplify the situation. I think I would, and just sort of thinking about that is, given the methods that do exist, you could look at your sort of non-parametric type methods, Mann-Kendall type tests, and and I could say that 10 years ago I had one student do one and one student do do the other approach, and they actually match pretty well. I think the other issue is where you're doing your monitoring, given that there clearly is a assimilative capacity in the airshed, particularly for compounds like sulfur dioxide. Okay, they largely show very flat signals spatially from an emission source. It's a bit different for some of your other pollutants, given the multitude of sources from where they come from. But I think where you do your monitoring, in this case, we focused on community stations to represent sort of potential population exposure. I would suggest that they are the right locations for that. And, I guess I would question whether there are sort of much better or refined methods that's going to give you a signal. If I could just suggest that that can be established by having sort of robust data with a longer term data set. If your inputs to the system are large enough, then yes, statistically, you will see them. If your inputs are not, then not large enough, then you're not going to see them.
He's ready to go afterwards. I think he wants to. Oh, we got one more.
No, maybe Diane?
No,
Okay.
you're-
I just have one question related to the term, and I'm dating myself, but I started at Syncrude in '79, and I used to calibrate our air monitoring network in the early '80s. So I know that when WBA was formed, '97, okay, there is data that happened before that. So I'm just curious why you would not use the historical data before 1997.
Okay, that's actually a very good question, Dan. The station moved just prior to 1998, and there would be a difference. Okay, so where they were monitoring prior to 1998 was right beside the property where the Fort McKay Industrialization Corporation's offices were, and the data that we use were from the station that's north of Fort McKay. For your other stations, that is possible to do that. But what we wanted to try to do is compare everything for the same time period. But your point is very good, actually.
And just one other comment. I think it's a positive that we're not talking about uncertainty of data close to a baseline and therefore not being able to even measure if there was a trend. Because I think going back about 10 years ago, other people have written reports, and basically the key finding was you're not spending enough money on the instrumentation because we don't have confidence in those low values close to zero. So I think my takeaway is that we're making progress. Would you agree?
Sure,
Yeah.
sure. That was easy.
that was supposed to be the first question.
Hi, Andrew Reid with Femina. One aspect I'd be interesting to see for the comparison, I noticed you compared to the Alberta Ambient Air Quality Objectives, which is a great comparison. Now we have the Lower Athabasca Regional Plan and the Air Management Framework underneath that, and an additional piece that I think would be really helpful for decision makers would be comparison to those management triggers of that data as well, so that we can have a greater understanding of the current state, because that ambient air quality objective is a single number, and I think those management triggers allow us to have a better sense of the general state of the airshed overall.
Okay. Your question is very fair. And the way that I'm going to respond to that is I had indicated in one of the slides that we actually published data was based on 15 years, and very specific. The peer reviewers wanted to understand, with regards to these types of benchmarks you're referring to, were they government-based, for example, all right? So you can define various benchmarks for using various types of data, and I've done a lot of analysis for various jurisdictions, and the benchmarks that we are using are sort of accepted throughout the province of Alberta, and I think that's very important. From my perspective as a scientist, it allows me to compare air quality in Fort McMurray and compare it in Edmonton and Calgary, and then try and understand what's happening. So from that perspective, I would judge these benchmarks to be acceptable.